check again. Okay, this is for the first joint, second joint coefficients, third joint coefficient. Okay, so let's see why it's not concatenating here. Oh. Okay, we should be fine now. We should see all the three together. Okay, that is the set of coefficients. This will define the Q1 trajectory, Q2 trajectory, Q3 trajectory. Okay? All right, now that you have A, we need to plot all of this, right? So once again, it's going to be A's. Let me do. So first thing we'll do is we'll linearly space time. We'll call this here. We'll say we want to space time linearly. Okay. Next, how do I generate the trajectory? We can use the same thing here, but then we know that, okay, so we'll have to do the following. Let's do this. Okay, now A is a double dimensional array. It's not a single dimensional array. The column tells you the variable number. So for example, this is A0 for the first joint, right? We are trying to plot this joint by joint. So this is A0 for the first, this is 1, 1, right? Now this will be 1, 2. So the second variable, column number, will give you, so this will be comma n. Okay, so this is for the first joint. And then we can put this whole thing here. All right, let me do it for, we'll do it for one joint and then we'll do it for the other joints also. Okay, let me just hold on for 1 second, let me plot this out. Fine. Fine. Okay. So we can go back to doing this till 3. Okay, here we'll have one issue because we want to plot, we'll plot all the three velocities together, all the three accelerations together and so on. So in this case, let me see what this is equal to. Once I know what it's equal to, we can, okay, it's a row matrix, fine. So we'll have to set up Q here. this is a row matrix. So we'll have three rows. First row will be Q1, second row will be Q2, third row will be Q3. Same thing here. First row will be velocity of the first joint. So let me plot the three joints together. Let me go here. Let me comment this. And I think, if I'm not wrong, this should be vectors must be of the same length. Okay, fine. So let me so this will give you the three joints together, okay? These are the first joint, second joint, and third joint, all the three joints together. So now you can plot all of them. That's your joint acceleration, your joint velocities, and your joint angles. Obviously, you can also write a function to do that. The first one is pretty much straightforward. The first example, you can just change the code that we have, the first code that we did. And the second example, you'll have to program it. The first one is simple. You just change the values in the code that we did today. The second one, you will have to change the, let me have the sheet. For the second one, you'll have to set up a different T matrix because now you're talking about a quintic polynomial, right? So you'll have two more columns and two more rows. So it will be a 6x6 matrix, not a 4x4, okay? And you'll have starting and stopping accelerations. The last problem is a problem of a via point, okay? So in the last question, you're going from A to B, in between you're stopping at C, okay? So let's try to do that, and if you have any questions, I'm here. So for the last question, this is what you will do. You're moving from A to B, but you're stopping at C. So this is A, you have a point B, but in between you're stopping at C at some time here, okay? So your trajectory will be like this. You'll go from A to C first, and then from C to B, right? So in this case, here you have initial is QA, VA, and acceleration, let's call it as AA. Here, you will have QC, VC, and AC. Same thing here, set of values QB, VB, and AB. Okay, acceleration and this. So the first trajectory, you'll generate this as your initial. This will be, the first trajectory will be from here to here. Okay, this will be the first trajectory from A to C. And let's say this time is, this is T0, or I'm going to call this as starting, we'll call it as T0. Time to be at C, and this is your final time, TF. Okay, so in the first trajectory, your starting time is T0, stopping time is this. This is your initial condition, and this will be your final condition. Okay, when you do the second trajectory, which is this, from here to here, this will become the initial condition, and this will be your final condition. So if you have trajectory T1 and T2, your total trajectory T will be equal to T1 and T2 joined together. Okay, so when you plot this, you should plot, when you plot the Q, or just as we did all the plots, the plot will be like this. It will be an S to C. So let's say this is A, it will go to C, and then there will be another S plot to C, because you are joining two trajectories like this. So this is your, at this point, this is T0, this is TC, and this point will be TF. Okay, if you're using a cubic polynomial. There's only one gun. For the above case, find the coefficients of the quintic polynomial equation and initial and final accelerations of this. Yeah. Change that to 6 or 8. Yeah, you can. You have to change. You have to change the Q array. Like if you have 6 jobs, right? So it becomes 6. It will become 6.